This call is now being recorded.
Okay. So I've started the recording, and once the session gets over, we'll put the link for the recording on YouTube. All right. So we were talking about like how the course is divided in MLF. So week one, you will just look at what the basic concept that basic terminologies that are being used in ML. So all these things you will study in great detail when you go to the MLT courses, or if you are already doing the MLT course along with MLF, then it will be more clear for you, like if you are doing it parallelly. But for the people who are doing MLF first and then moving to MLT, it's okay. So just learn the terminologies and like the definitions, what exactly it is, and then later when you move to the MLT course, you will learn these things in detail. So week one is just the basic idea, and then week two is the calculus part that you have also studied in, I suppose, in maths two. So it will be like a quick revision for you in the calculus part, where you will come across linear approximation, higher order approximation, and so on. Then from week three onward, you will start your linear algebra. So week three is the linear algebra. Week three is where the linear algebra starts, and it goes on till week seven. Okay, so you will learn about various matrices, the subspaces, SVD, PCA, and so on from week three to week seven. Then there come the optimization part. So from week 8 to 10, you will study the optimization, which will also be covered in great detail later in uh, MLT. Okay, and then no, I'm not sharing the screen. I'm just going through what the content is. And then week 11 and 12, you have the statistics parts, where most of it you have already studied in stats 2. Okay. Only very few topics that you have not covered in stats 2 is there in this week 11 and 12. So yeah, this is how the this course is designed.
Ma'am,
Uh, yes.
ma'am, compared to Max 1 Stats 2, what is the difficulty of machine learning solution?
Compared to maths 2 and stats 2, how is the difficulty of ML, if you're asking?
Yeah, yeah, yeah.
So if you have yeah, like you have already cleared maths 2 and stats 2, and you must have heard like these are very difficult courses, especially stats 2. We must have heard it's very difficult. People come to this course with this perception. So MLF, if you look at it, it's not so difficult. I mean, at least the week 1 2 and optimization and statistics parts, it's very straightforward. And the linear algebra part is where you will have to work a little more. Okay, so the linear algebra part, if I'm not sure how much you have studied linear algebra in maths too, but you will be going through the linear algebra in great detail. Even you will be studying about the complex matrices. So if you like prepare yourself very well for the linear algebra, then I would say you will do well in this course. Okay, there are more questions. So stats 2 I need to revise. Can I revise it later before week 10? Any stats to uses before week 10? So no, you don't have to revise stats 2 for now. You can do it later. Till week 10, you are not going to come across any such terms from stats 2. So it's okay even if you don't revise it now. Like before you start week 10, before you start week 11, there is already additional content that covers a lot of topics from stats too. So you can uh, go through those topics, and quickly you can go to week 11 and 12. So The second question is most of the starts to content focused on week 11, 12 of MLF? Not, I would not say most of it, but like if you look at uh, this time starts, so you have looked at the joint distribution, and you have looked at joint distribution, and then conditional probability, marginal, then CLT, estimation, hypothesis testing, right? So in MLF, you will be studying all this from week 1 to week 6, I would say, whatever you have seen in week 1 to 6, that you will see in week 11 of MLF. So for sure that like it covers all the topics, even in a way kind of the same pattern it follows. So yeah, it is there, and some parts that is not, uh, and there will be some part that is not, that you haven't studied in starts too, so it's okay. uh, okay, so maths to uh, yeah, MLF lectures will be good enough to get the concept, but again, like in maths too, you must have studied things in more detail. But here, you will be not studying things in very detail. So I would say you will have to work a little more on the maths part. So I wouldn't say you revise the maths too again. You just focus whatsoever is done in MLF.
Ma'am,
Yes, Naira.
uh, is this a doubt clearing session or just an introduction to MLF?
No,
Because
no,
I do have
it's, yeah.
a few doubts in MLF, so that's why I'm asking.
Yes, yes, we'll start. I saw a lot of questions in the chat, so I was taking it. But we will start the MLF topics.
Okay, fine.
Yeah.
Ma'am, before this, I am just having a request because in the calendar, DBMS and MLF are just overriding with each other. Just there is no big difference between the two.
Is it? So okay. Thanks for informing that. So I will let people know that it's clashing. So
Yeah.
DBMS, is it just today or is it
No,
both
ma'am.
days?
Every day.
Okay.
To Thursday, Saturday.
Even the timing is same. You are saying.
Yeah. No,
Yeah,
not that
it was
overlapping. Actually, the timing is are
back to
six
back.
to eight and 8 to 10, and but the lectures get extended to 3 to 3.5 hours. So that's why we are facing the
Okay.
problem.
No, no, no.
No,
There is a
no. There.
partial. In many days, it is a partial overlapping is there. It's
Yeah,
not that.
overlapping is there.
Yes.
So can you tell what overlap is? Like if you're saying if the session starts
Ma'am,
from
the BDM project session is going on right now, actually. So
BDM
that is,
project session.
yeah, so that is overlapping with this.
Okay, and what about DBMS? So DBMS,
For example, next week,
yeah.
Monday, Tuesday, Wednesday, Friday.
Okay, I will tell you. I think it's not the instructor-led session. So from this term onwards, you will not just go through the instructor-led session, but even the TAs that we have for the course, they will be taking our sessions. They will be taking the session for each of the courses. So I think
No, no,
what
no. What we request is at least even that course is useful for the students. Why don't you really plan not to overlap?
uh, see, even we don't want the courses to overlap, but a lot of courses are happening parallelly, so it's little difficult to accommodate each of the courses. There will be some overlap, but we will see if it can be rectified in a way. Okay, so currently, can you tell me what course for with what course it is clashing?
Ma'am, DBMS and MLF,
Also, it's
TDM.
it's the same, it's the same timing also, 8 to 10.
Not the Actually not the timing. The lecture started at the 6 p.m. onwards, but the it get extended to 3 to 3.5 hours. So in that way manner, so there is no miss. We cannot end that. We just enjoying this one. So there is
uh,
no gap within this.
Yeah, I would say in that case it's little difficult to like accommodate that. But if it's like it's it's exactly same with the complete overlap, then in that case we can do something. But 6 to 8
Ma'am,
and 8 to 10.
BDM is
Ma'am, for
complete
me, it's
overlap.
Yeah,
BDM.
I will check from my side, okay? And if
BDMS
it's
and PDSA completely overlapping. Like both are starting at 6 p.m. only.
wait, BDM or MLF? BDM or PDSA or BDM or MLF?
All, ma'am. Like some are partially overlapping, some are completely overlapping. Like
Okay,
BDMS and
okay,
PDSA completely.
okay. I got that from
It's a
the.
request. At least the main lecture should not overlap, please, because on Thursday as well as on Saturday we are having the main lecture for both the subjects.
Right, right.
So
Okay, I will check. So BDM and MLF are overlapping. I will check, and if something can be done, I will do
yeah,
for it.
we can just transfer them in such a manner that TAs get shifted to these days.
Let's see. We can try.
Okay,
Yeah,
ma'am.
yeah. Okay. Is a schedule. Okay. The record, yeah, the YouTube link is not there in the calendar, I suppose. But I have started the recording, and these recordings will be uploaded tomorrow. So, and the YouTube link will also be updated there. Okay. So from next time, we'll take care of this. That the YouTube link is updated. All right. So okay. All right. So let's start week one. I see one question over here from Nanda. Difference between the regression and the classification. Okay, let me share my screen first. Okay, so the first question that I got is what is the difference between a regression and a classification? So,
Ma'am, before this process, will there be a solve with a session for the MLF or not?
the solve with the session will be there, but it's on Saturday.
Okay, ma'am, because there are the two sessions for week one. One is for the open sessions and another was same name open session.
Uh, I didn't understand.
Ma'am,
You have tested.
actually during foundation course stats 2
Hmm?
there were
Hmm?
three lecture for the
Right,
one
right,
subject,
right,
but
right.
for this for this MLF there are
Hmm.
two lectures get assigned for this week one.
Yes, yes.
So there is, I think there is not a solve with the session. So will
Uh,
there be the solve with the session?
there will be a solve with a session. So today is open session where we will take your doubts if wherever you're facing, and we will do the activity or the practice question if you have the doubts there. And the next session, and in between the solve with us and today's session, you will have one more session on Sunday, which will be taken by the course TA. So there also you can join, and if you have any doubt, you can clear your doubts there. So yeah,
Sunday is not there in the calendar, ma'am.
it should be there in the calendar.
No, it's not there.
It is not there, is it? Okay, so I
It,
will write, I will write that also.
on
Open
Tuesday
session TA, it is on
it is.
Tuesday. Yeah.
Ma'am, can we begin the session of conceptually now
Yes,
because it's
yes, yes,
getting too much late.
yes, right.
Yes, ma'am.
Okay. So the first question was what is the difference between regression and the classification? So in any answer for that, I saw that somebody had also posted in the chat. Uh, yes, Kaganjot, you want to say something?
Now, regression basically predicts a numerical value, but a classification, I guess, predicts a label, like in a yes or no, positive, negative. This is what.
Yes, yes. So whenever your model predicts a continuous random variable, right? When your label is a continuous random variable, such kind of tasks are performed by regression. But when your goal is to just classify your data, right? So when you just want to classify your data, so I'll just go to classification part here. Okay. Okay, so when your goal is to just classify the data into different classes, so let's say you have class 1 and class 2, like in case of binary classification problem. So if you are able to put your uh, problem into these two classes, then such cases it's called a classification model. Like for example, the first example here says predicting whether an email is spam or not. So okay, can you keep yourself muted? Start. Okay. So, for example, you want to, in the first example, you're saying predicting whether an email is spam or not. So, you want to check, given an email, you want to check whether it's spam or not. So, you want to classify your email. So, if you have email, you want to put it in two buckets here. So, either it can be spam or it is not spam. Right, this is so you're just putting it in two buckets, spam or not spam. Then second example is predicting whether the patient is having cancer or not. So again, given a patient, like if a patient come to you and this is to diagnose whether patient have the cancer or not. Again, it's just two different class. So the first class will be cancer, on the second will be not cancer. So again, it's a we call such kind of problems as a classification problem. So can you think of more such problems in the classification? Can you think of more examples from classification?
Whether the you can maybe sort movies based on their reviews, like reviews movies with reviews more than 3 stars, something like that.
Right, right. So I can have let's say I can have five different class labels for the classes. So I can have the reviewers rate, in a way I can say rating like 1, 2, 3, 4, 5. So I can put the movie's name into these five buckets, right? So again, this is a classification problem.
Test passed or not.
Yes, then you have test, given a test, if you have a test and if you pass the test or not pass. So again, such kind of problem is a classification problem. Now what happens in like what is the difference between a classification and a regression is, in the case of regression problem, you want to predict a numerical value of the label. So in this case, your the function, the model, it takes the parameter, the input from rd to a real number. Okay, so takes a real number, and in the case of classification model, it's just a function from rd to the label, so +1 and -1. So the some of the examples here for the regression is predicting the price of land based on its area and distance from the market. So here you have some of the features given to you. So what do you want to predict? You want to predict what should be the price of this land, right? And the features are how much is the area and what is its distance from the market, right? So there are two features here: area and distance from the market. And whatever the price, and the price again will be a real value. So it's a regression model. Then you have predicting the amount of rainfall in 2022 based on precipitation data from the 2021. So again, the rainfall that you measured is uh, okay. Who is there? Shalendra. Yes. Yes, Shalendra.
Yes, well, a small doubt in the classification model
Okay.
is the only the classification model is only the plus and minus, or maybe more choices means It is a rating 1, 2, 3, 4, 5, 6.
Uh, so we saw both kind, right? So if it just if you're talking about the binary classification problem, binary classification, there you have just two classes. So there you will
Okay.
have spam, not spam, right? But we also then the second example is whether the patient will have a cancer or not. So this is again a binary classification problem. Then we also then somebody also told that if we want to, like, let's say you have some objects and you want to put into the bucket of, let's say, fruits, vegetables, toys, right? So again you will have three different bucket for that, you will have three classes for that. So this depends on the how many classes are you talking about here.
Okay. Thank you very much, ma'am. Right.
Yeah. Okay.
So, ma'am, all these models are basically some kind of functions, right?
Yes, it's a function.
Okay. Can you explain that? You have written the function once. Like, uh, how
Okay.
would it seem?
How
The
would it seem,
regression.
right? Yes.
Yeah.
So okay, so you have the data set, right? So you have the data set as a label data set you have. So again, before we go to label data set, you have seen there are two types of model. One is supervised, other is unsupervised, right? So in supervised, you see your data should be labeled. So regression comes under the supervised learning. So you will have a label data set. So you will have let's say this x1, this is a data set, and the label associated with this state with this x1 is, let's say, y1. Okay, and so on. So you have the second data set, which is a second feature, that is x2, and the label associated with it is y2, and so on. So this is the data set given to you. And now again, this xi, so if I, in general, if I write for any xi, so I am saying this xi has d feature. So it is going to be a vector, in a sense. So you will have x1 1, x1 2, to x1 d. Okay, so for example, you can take the housing problem that you have seen in the lecture. So it says you want to predict the price of the house based on the area, number of rooms, and the distance of the house from the metro, right? So what is going to be excised there in the housing problem? You have you want, so what you want is, the problem is you want to predict the price of a house depending on the number of rooms, its distance from the metro, and the number of and its area. Okay, so what is going to be your x1 excise there? So if I take that example, what is our excise? Any guesses?
Distance,
Number of bedroom.
number of rooms.
All these variables.
Okay, somebody said distance. Anybody else?
Number of rooms.
Number of rooms.
Number of rooms. Okay, anybody else?
Ma'am, features?
Area.
Features.
Area.
Area. Let me write the problem statement first. So the problem statement is uh, you want to predict the price of a house depending on area, distance, and number of rooms. Okay, so what my question is, what is your xi here? So you see this label data set given to you here. So what in general, if I take an xi yi, so on the basis of this with respect to this example, what is your xi and what is your yi? That is the question.
And
And why
the
is
data
the price,
instance,
right?
Y is the output in
and
amount.
yi is the label
Okay,
concept.
one by one. So what is xi?
Xi is all the area, distance, and number of rooms. That all parameters.
xi is basically a vector containing all the features, area, distance, and number of.
Right. So what can
XI
it
is
be?
very
Yeah.
Ma'am,
Particular
So
house.
yes,
xi
particular house, but
Yeah.
house, ith house, I can say, right? So I
Yes.
give you a house and you want to predict this yi, that is the price of the house, right?
Price of that house.
And again, this xi, which is the ith house, it will have three features, right? The three features will be area, distance, and number of rooms. So if I take this example, my xi is going to be, it's xi1, xi2, and xi3, right? So it has three
Yes.
features. Okay.
Yes, ma'am.
So that is why we are writing that your algorithm should output a model that is from a function from rd to r. Okay. So that this is the reason we are writing that f should be a function from rd to r. So each of the vector is in rd space, and it will give you, in the case of regression problem, it should give you a label, not label, it should give a real value. Yes, Naira, you have doubt?
Yeah, my question is, so yi will be one dimensional, no? Because it will give you the output.
Yes,
Okay,
one dimension.
okay. That is why we are writing r raised to d will give you r. Okay, like
F
the
is a
function.
function from, yeah. So
Yeah,
why
yeah.
RT is because
Any
it will take this
any
vector,
dimension.
it will take this vector which is in RD, right?
Yeah.
And it will give you a real value. That
Okay.
will be in this case, that will be the price of the house.
Okay. Okay. Got it. Thank you.
Yeah. So what we want is, we want to get such model for which this fxi turns out to be approximately equal to yi. So we want such f. Okay, we want such f such that fxi is approximately equal to yi. So what will happen is you give this label data set to
Excuse me, ma'am.
yeah. Yes, tell me.
How can we directly predict this model?
Sorry, I didn't understand. Can you repeat? I mean, what do
How
you
can
want?
we predict the, how can we directly predict the best variable for a model?
Okay.
Like if you have a function of f of x is equals to ax plus b, then how can we predict that a and b will be best fit for this model?
Yeah. So in that case, let's say I have come with two different models. Okay. Now you want to check which model is the best one. So to check that, you can calculate the loss. Okay. So to evaluate your model, there is a loss function, and you can find the loss using this formula that is also called sum of squared error. So this is like you see, basically what you want is at the end that your fxi should be approximately equal to yi. Okay. So you will always want that your model gives you the least error, the error should be minimized, right? So let's say I have a function, a model f, and I have a model g. Now what I will do is I will calculate the loss associated with the function or the model f, and I will also calculate the loss associated with model g. Now whichever gives us the least loss, so that we should that is what we should select. So here we're just talking about two models, but it can be like various models, and from there you will have to select when it comes to a real life. So this is just to understand like how do you evaluate this model. So to evaluate a model, you go with the loss function, and the loss function is defined as 1 by n sum over f of xi minus yi whole square.
Hello, ma'am.
Yes.
So every time we want to know the best means best variable for that model. So if we have a finite set of values, then we can calculate the loss for every function. But if we have infinite set, then how can we just go for that?
Yeah, again, so we are not again, this is not what we are going to do manually, right? You are going to there is going to be your some algorithm that calculates all this and gives you a model. So in real life you're not going to calculate all these things by hand, but it's just algorithm that is giving you these models.
So, ma'am, when will we learn these real-time algorithms? In which course or?
You will learn in MLT. So this course you are just going to study the basic terms and the concepts that are needed for to actually doing the machine learning, right? So
Okay.
these are the things that is the foundation for machine learning. I saw one hand raises. Okay. Uh, Somebody had any doubt? I saw some hand raised, but I couldn't see who is it.
Ma'am, what would be the input for the learning algorithm?
So the input for the learning algorithm will be your label data. So the label data set that you see here, right? So that is going to be the input, and the learning algorithm will give you the model. So model, as in the best model, it will give the learning algorithm.
Ma'am, we also have to supply the models, right? The possible
Yes.
list of models.
Yes.
So that's also an input?
That's also an input, because at the end it should give you the best model that it can provide for the training data set. On the basis of the training data set, it should give you the best model out of all the models that are available to you.
And
I
in the videos, a professor mentioned that there would be an infinite number of models that would be
Yes.
supplied.
Yes.
Ma'am, where would they be sourced, such infinite quantities of models?
So okay, I'm not really sure where it will be sourced, but definitely we'll study that in the next course.
Okay, ma'am.
Ma'am,
Yeah. Yeah, if
ma'am,
somebody knows
I don't
about it.
understand.
Yeah. Yeah, tell me.
Yeah, I don't. Can you explain how the validation data is used?
Okay. Yeah. Uh, okay, I see a lot of messages in the chat box. Okay, so I will look at the chart later. So yeah, again, so you have the data set, and you split the data set into three part, right? So you will have one a training data set, then you will have a test data set, and you will have a validation data set, right? So training data set is what you use to train your model, and to test, like to check the performance of the model, use the test data set, that you keep it separate to test, because you don't want to like use this data to train the model, and because later when you have to test for a new data set, it won't work very well. So that is why we keep the test data separate, so that whatever model we have got from the training data set, we can evaluate that model using the test data set. Now what does validation data set does? So it is just to use like it is used to like for model selection basically. So model selection as in like how what you want to do is like you got a model from the training data set. Now you want to see how this model is going to perform for the unseen data as in like in the test data, how is this going to perform. So to check that those things like how whether your model is underfitting or it's overfitting, how is its
Yeah.
performance, to check all this use your validation data.
But ma'am, this validation data already included in the training, right? So then it will
No,
fit perfectly.
it is uh, uh, it is not included in the trading, right?
It is.
No, it is not included in the
It is
training
not.
data.
You divide it into three separate. Like if you have a data set, you like
No,
divide
what I
in.
understood from the training material is that training data set, okay, approximate 80% of the total, and validation is 20% of the training. Then test is 20% of the total.
20%, 25% of the. Okay.
Validation data is from the training data, but test data is different from training data.
Yeah. Test data is okay. That is unseen data, but validation data is not unseen. It's already
Yes, yes,
in.
it is a part of training data. Yeah.
Yes.
Yeah, it's a part.
Yes. Fine. So it's a part of the training data, but you use that data to check the performance of the model, basically. But how
But
exactly
the
it is
performance we
done?
can
Yeah.
understand from the training data itself, right? So how a small part of the validation data can conclude the model.
No, no. Right in the screen, it is given. Validation data is not part of the training data and test data.
See, in
Right
the
in the screen.
lecture, it has been told like it is different from the training and test data, but some of you are saying that it's contained.
No, in the lecture it is.
Uh, okay,
Definitely, training
let
data
me
and test
cross
data.
check.
Training data
Let
and
me
test data are not same. But only the
let me
validation data
cross
is the
check on
That
the
okay.
second.
That means we don't have 80% for the training. We will have only 60% for training.
No, we'll have almost 80% for the training for sure. But I will cross check this part and we'll get back to you on this. Okay. Uh,
Okay.
yeah. Uh, all right. So before we go to classification,
Uh,
yeah.
in the lecture, the test is passed, but the validation is failed. Can you give the example for something like that?
Wait, see a lot of noise coming in. If you're not speaking, you should keep yourself muted, okay?
Am I audible?
Yes, you're audible. You're audible. Can you please repeat?
I just said, like in the lecture, there is an example where we have a test data, like we pass the test by solving, like by solving the equation, and on the validation part it fails. Can you give that example? It's not clear.
Okay, the example, maybe I will not be able to give right away, but sure, we can take it in the next session. I'll just write it down for. Okay, so one was,
Ma'am,
uh, just give me a few seconds. Wait. So one is validation data, and the second part is where validation data frame. Okay. Yes, Naira can go on. Uh, yes, and that is right. But yeah, like many of them are saying that it's contained in the test data. So we'll just look at it carefully and then we'll get back to you. Uh, Yes, Naira, you had a question. I suppose. Am I audible?
Yes, ma'am. You're audible.
Yeah. You have any doubt? You have raised your hand.
Yes, I have a doubt, ma'am. The in the practice assignment, could you just explain how to do the last question? I think it's to use just formula only. If that is so, then I don't think you have to explain once again. Else,
Uh,
due to some other method of doing it, please.
all right. Let me share my screen. The last question, right?
Yeah, last question of practice assignment.
Okay. Somebody has raised the hand. Pritika, you have any doubt?
Oh, yes, ma'am. Actually, the validation data which is there. So, like, once we are choosing the model, after that, then what is the need of a validation data? Because already we are chosen the model, na? And then only we are training and testing it. So,
No, what we want is we want to like we have a model, but before like testing that model for the test data, we want to know how efficient is it. If it's overfitting, underfitting, or if you need to do something to do do some generalization for the model, just to check the performance that it can have on the new data that you provide, just to get some insight on it. We use the validation data.
so that is the first step, no? To
First, yes. So all this, when we go like when you actually start learning the ML problems in the new next course, you will look at these very carefully.
Okay, okay, ma'am.
Yeah. Okay, so week one practice assignment. Okay, so in question number 12, I suppose you have the doubt from the encoder decoder part.
Not encoder decoder part. It's something about the loss only. So I think it's that formula that we just discussed before that we have to use it
Okay,
there.
the
Yeah.
reconstruction, the loss. Yes, yes.
Yep, yep, yep. If that is not the case, if there's something new, could you please explain? Otherwise, yeah, I think we would do.
Okay.
Ma'am, actually, the question is based on the density estimation part. So, can we just move in a flow? Because breaking that, there is the hassle in the session.
Uh, yes, I understand that. Okay, we can go in a flow. That's better. So I've noted down the question. I can take it up when this part comes. So next is Sanju Das. You have any doubt?
Yes, ma'am. Good evening. I just joined because there was another class regarding that decentralized data management. So my query is regarding training set, test set, and validation set. So training
Yes,
set.
we were just discussing about it. So yeah, tell me your doubt. We had where the problem that we had stopped in between because like there are two different places. It says two different things. So I will just cross check it properly and correct it, and then I will get back to you on the validation data part.
Sure,
If you
sure.
have doubt from there.
Yeah, sure, ma'am. No, actually, I was also searching in internet. The validation set is used, I think, to fix the parameters, right?
Yes, just to fine tune the parameter. Yes.
Right. So, and training is used to fix the model that find the
training is
optimal model.
used Training is used to, yeah, train your model, like yeah, that is
Right.
what the learning algorithm takes and give you a model. Yeah.
Exactly. So, ma'am, which one do generally people use first? The to select the model or to select the parameters? I mean, do we fix our model on validation first, or first on training, then validation, then on test?
First on training, then validate,
Okay.
and then you evaluate.
Okay. But suppose we have suppose say let's say we are taking a quadratic model.
Okay.
Okay. So if we fix the quadratic model itself on a training data set, then again using that to find I mean we are fixing the model in this now training, right? Finding the
Right.
optimal model.
Right.
So isn't it to we are already getting the parameters itself from there?
Yeah, we are getting the parameters, but again,
Hmm.
we need to see if the model we have gotten, like how it's going to perform, or if we have to uh, something for that model to, so that it best it gives the best performance for your test data, right?
Ma'am, if it is failed, then we will go back to our training sets back. So, what's the point of checking?
Yeah, so all that, again, like right now you don't have to go so much in detail, because you will study these things in very detail later in the course, when you study MLT. So you will come across various examples and see how exactly it's working. So no need to worry right now, but later you will study this properly.
Okay, ma'am, understood. Thank you.
Yeah.
Ma'am, one last question about this. Is it fine if I ask?
Yeah. Go on.
Ma'am, you mentioned that the order of usage would be training and then validation and then test. Is that right?
Yes.
Ma'am, the training data would then provide an infinite number of models, and the job of the validation data would be to pick out a finite number of models from the infinite that has been supplied by the training data. Is that correct?
Uh, Not really. Like training will give you one best model, one model from the learning algorithm, and then you check. Okay, can you repeat? You said training will give you.
Ma'am, training data will be supplied by us in the form of giving infinite number of models, and the validation data would be picking the best model out of the infinite number. So finite number would be taken from infinite numbers.
And previously,
Mm,
one of your slide was showing training, test, and validation. No,
no,
now you are telling.
training, validation, and test.
I think it won't give by default infinite number of models. So based on the parameters, we can create multiple models, then do the validation, then check the mean squared error and check whether which one is best fitting. That's what my understanding.
The basis for selecting is the minimum of mean square value, minimum of error values. No, that's what ma'am was telling. So once you select it, then you got to really do the validation and then the test the model. No? That's the order in which it will be progressed.
Yeah.
Okay,
Again,
then
we'll get back on this in a proper way, like how you use the test, training, and the validation data. So again, this is not a part of this course, but
I think it's a
yeah.
graphical explanation
Hmm.
with the sample data and basketing it on training, test, and validation data set. Then how the real data flow is happening might be helpful instead of words.
Yes, we'll
Graphic.
get back to you. Like in the next session, definitely we are going to talk on this in great detail if you are interested. So for now, we can like pause that topic, and we can maybe look at different other topics here.
Okay, ma'am.
Yeah. Okay. Okay. We looked at the regression problem, and we had one example here. So you have. So again, you have the data set here x1 x, and you have the label data set that is y, right? So can you tell me what is the dimension of the data set x? One dimension, right? Now I have defined fx to be x square minus 2 by 5, and we have evaluated our fx. Now we want to calculate the loss function. So can you do it and check what the loss is coming? So again, I will write the loss function here. So you have to find the loss. So it is 1 by n sum over fxi minus yi whole square, I varying from 1 to n. Can you check what is the loss that you're getting here? So once you are done, you can raise your hand, okay, so that I know if any of you have done it. Okay. Shayan Vibhuti. So what is the answer that you are getting?
I'm getting 3.
You are getting loss to be 3. There is someone getting 3.4. Okay.
Vibhuti, 3.4.
Okay. Okay. Any other answer for this?
And this 3 or 3.4, does it mean like, what is it, like percentage or something? Because we are anyway not multiplying by 100, so it shouldn't be that.
Sorry.
3.4.
No, like loss in the sense, let's take one value of y, 2, and if you're getting
Huh?
using that model, if you're getting the answer as 3, you can say you have a loss of 1, right? But
Loss
in
of?
this case, loss of 1. See,
Okay.
if you're taking one element of y, that is 2, and if you're using model, and if you're trying to find out the value and you're getting the answer as 3, or in this case 0.2, then you know
Uh,
the answer will be 3.2, no, the loss will be.
Sorry, I'm not
But
able
this
to
is 2.
understand what you're saying.
Okay,
I
let me
think
know.
there's some noise coming from the background.
Hello?
Yes.
3.6,
Hello?
3.4, ma'am. 3.4.
Yeah, I see majority of you have got 3.4. So
Yes,
yes,
yes.
that is the right answer.
Ma'am, my
Yes.
question is,
Mhm.
here you have for each value of x, you have y. Now let's say
Yes.
you're only taking one value of x, that is 1. Just
Okay.
we are just taking that into consideration. Then
Okay.
you have y equal to 2. And when you're using the model and when you're implementing it, you're getting the answer as 0.2. If
Yes.
that is the case, the loss will be minus 0.2 minus of 2, that will be 2.2 whole raised to square. That is whatever that value is, you will
No,
get that as the loss.
what is your fx? Your fx is same as x square minus 2 by 5?
So my question is, when you're saying loss of 3, what does it actually mean? Like, see, when we're saying we have 3
Okay.
percentage loss, it's understood. Or 3
Yeah, so
percentage.
yes, again, so what I had said earlier is, let me go up. Wait, got stuck. Just hold on.
Yes, ma'am, continue.
Yes. So what I had said earlier is like you will have let's say when you have this I'm just giving you a small example so that you know, like if you have to like given 2 3 models to evaluate, and then how will you pick the best one. So you calculate the loss function, you calculate the loss for that function, and then you pick that function that is giving you the least loss. right? So this example is not to not for like what is this loss mean here. It's mostly like how do you evaluate this loss function if it's given to you. Okay.
Yeah, oh yes,
Ma'am,
I get it now.
ma'am,
Thank
can
you.
we say that okay, the values, the expected value from the model can deviate square root of this loss value? So
Could you
that is
explain?
the result, right?
Yeah,
When we are getting this,
that is the result, right?
But
Ma'am,
how
if
is
I
it
may just
possible? How can you square it and get the expectation value? Expectation value is basically like what you're expecting the most of. In short, the average. So,
Yeah, if I may if I may say something here, actually loss is
Yeah.
kind of like deviation from the which is the actual value, and you are predicting something. So loss
Right.
yes,
is
Right.
basically the deviation. But as we
Right.
sum up, if because sometimes the deviation will be positive, sometimes it will be
Right.
negative.
It will
So
cross it.
cross,
Yeah.
so it will cross out and it will be zero.
Yeah. It can
But
become zero. Yeah.
right. So to mitigate that issue only, we take the square. So you can think a loss is kind of a deviation only, square deviation, you can say. And
Yeah.
here it's not percentage or something; it's just a square deviation from the actual predicted square deviation of the predicted value from the actual value.
Yeah,
okay,
so you
okay,
can
got it.
think of more of it like in stats you see for the variation again for the variation you do the square, or let's say for the standard deviation you do, so you do the square because if you just because we know we're just interested in what's the difference between the central value to the given value, but it will cancel out and it will give you the zero. So to avoid that we do the square and take the average. So it's kind of the same thing that we are performing here.
Ma'am, the last formula what you have shown in the previous slide is different from what you are showing now.
No, it is same, right?
Okay.
Yeah, it
All
is
right.
same.
All right. Thanks.
Yeah. All right. So next we'll go to classification problem. So in case of classification problem, we the algorithm outputs a order where the input is again from RD, and the output is either plus one or minus one. Now, if in order
Excuse me,
to
ma'am.
yes,
Uh, like up to what dimension we can take the values of the domain? Like we can take n dimension also, or finite dimension only, or
yeah, I
in
mean this RD, I mean this D can be anything, right? It can
oh,
be R to R also. It can be
finite or
from R
infinite.
to yes, it can be anything. I mean, we are just giving that it has D features. Your input has D
No,
features.
I'm asking whether it is finite or it can be infinite also.
Uh, it can be infinite also. If I'm not wrong, it can be infinite also.
Oh, okay.
All right. So, how do you evaluate the classification model? You just so in regression we are taking the s- sum of squared error, right? Here we again we what we want is we want to check if your fxi is approximately equal to yi, right? And in this case yi is either plus 1 or minus 1. Now if again this what is 1 here, it is just indicator function. So you want to just check if fxi is equal to yi. So if that is there, you give it as value 1, and if it's not true, you give it the value minus 1. So if you look at one example here, so okay, you have a data set that is x and the labels are y, and fx is defined as sine of x1 minus 3x2. Okay, so in the first exam, in the first data, like the first x1, what is your x1?
One.
1. What
Zero.
is x2?
Sorry, one.
So this just
Zero.
remains the 1. So is this 1 equal to this y1, it is true, right? It is, the sign of this is positive, right?
Yes, yes.
Yeah, so again it is 1, so I can give this as +1.
No, but it is sine of x1 minus 3x2.
Right.
So that is not worked out, no?
uh
You are
See,
comparing
x1 minus
x1 to
3x2.
Sine of 1 minus 0,
So
sine of
so
1.
this is going to be 1 minus 0. Sine of 1 minus 0 will be what? Plus 1.
1. Yeah.
And this is same as +1. So this is this matches with, so I can say my fxi is same as yi. Now
Okay.
look at
Yeah.
the second one. Okay, it says now you have sine of uh, 2 minus 6,
6.
which is
Yeah.
minus 4. Sine of minus 4, which is minus 1.
Right.
Man,
Yeah.
the header should be x1 and x2 instead of x.
Sorry.
xy, in the
Yeah.
table header it is xy, it should be
uh,
x1 and x2.
no, so this in general we write it as x, but you should say it as x1, x2, x3, and so on. Okay, and this x1 is your x1 of 1, x1 of 2, something like this. This is how it is represented.
Okay, so you have to read that way.
Yes.
Ma'am, I had one doubt.
Hold on, so is it from this one?
Oh,
Yeah.
no, no, no. Like from the regression one.
Okay.
Ma'am, so first, if we.
Wait. We'll go back to that first. Let me finish this. Okay.
Okay, okay, ma'am.
Yeah. So here we got the sign to be -1, but here it doesn't matches with the label +1, right? Again, look at
Yeah.
x3. So in x3, what happens is you have 3 minus 3, which is
Yeah.
0. So again, it is positive. So it is +1, and it matches with your y. Similarly, you can check for x4, x5, and x6, and it's you will get the same label as what your what your label is given to you for these x4, x5, and x6. So what should be the loss function? What should be the loss for this f? Someone has raised the hand. Rajiv, yes.
Yeah, ma'am. How sign of 0 will be +1?
Uh, okay, so I think I have not defined it right. Mm. So you will take it as plus only, like when it comes to only in the case when it is less than 0, you take it as -1. Otherwise, you take it
Okay.
as +1. So for greater than equal to 0, you define it as +1, and in case of less than 0, define it as -1.
In every case.
Yes.
Hello.
Hello. Can you hear me?
Eh, Yeah. In every case
Yes.
or particular case.
No, no, no. Every time.
Okay. Okay. Thank you.
All right. So what should be the loss for this? So again, see, the loss is defined as sum over the indicator function whenever fxi is not equal to yi divided by n, right? So basically, it's how many labels are not correctly identified divided by the total label, right? This is what it's saying, right?
So it's 1/6, right?
1 over 6. Correct? So this is just 1 over 6. So the number of labels which are not correctly identified divided by total number of data set. So it is loss is 1 by 6 in this case. Okay.
Ma'am, can I ask my doubt?
Yes, from regression, right?
Yes, ma'am. Ma'am, like I don't think there is a requirement of the slides, but
Okay.
yeah. So if we are calculating loss as the square of the deviations, but the actual value is not squared, so how can we compare that if one is squared and one is not squared?
Means.
See, whatever loss is coming, we compare that with the actual value to determine whether the model is fit or not. So like how is the square, the loss is in the sum squared error of the deviations, but the actual value is it's not squared, right? It is the normal. So how we can compare a squared with the non squared value?
I think the thing is we don't compare the loss with the values itself. We compare loss of the separate models and we take the model which has the minimum loss.
Okay, okay.
Yeah, I mean, yeah, what you said is right. I mean,
Yeah.
we are talking about the different models here, and we compare their losses and evaluate our model.
Okay, 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 okay.
Yeah, yeah. Okay. So next we have the unsupervised learning, where the data is not labeled. So if you see here, the data that you have is not labeled. You just have x1, x2 up to xn. So in unsupervised learning, you will study two parts here. One is dimensionality reduction, and other is density estimation. So again, dimensionality reduction, you will study, I think, in week 7 again in terms of PCA. So here it just like PCA will be one example for this. So okay, so what we do in dimensionality reduction is we have to define two models here. So one model that is you that takes the data and it gives you a data set with least less number of features, and you should also define another function that is called decoder function that takes the output that you obtain from the encoder function, that takes that as an input, and it should give you the actual data. So this is what it does. So again, the goal is that uh, if you again, this is a composition function, right? So you have f of xi. Now on f of xi, you want to you want to map this f of xi, and sorry, you want to take f of xi as an input for your decoder function, and you want your actual xi. So you want it to be as close as this output to be as close as xi. In that case only we say it is a good encoder and decoder pair. Okay.
Excuse me, ma'am.
uh yes.
Ma'am, encoder and decoder functions are inverses of each other, right?
They are inverses of each other.
I mean, they're
Not
inverse functions.
not necessarily, we cannot say that.
They should be, because
They
that's why
should
we
be.
can. Yeah, because
They
composite function can only be exist there.
yeah, I mean, they should be, but uh, like when you talk about the real life scenarios, you may not get the, like, you want this to give you uh, approximately the same value as xi, but it may not actually be true also, right? In some cases, but you would
It
want,
cannot be, ma'am,
yeah, but
because
you would want
both of
your
them having a different dimensions.
yeah, but you would want your f and g to be in such a way that if you perform this decoder function on your f of xi, it should give you xi.
So ideally, they should be inverse functions, but in most cases, they're not. Is that right?
No, no, I think it cannot be inverse because the dimension is different, right? Both the number of
dimension is
variables are different.
Dimension is different, yes.
So as we are reducing the dimension and then recreating the value from a reduced dimension to an increased dimension, I think because of the loss of information, it is not possible to be inverse in most of the cases. Because when we are reducing dimension, we are in a way losing some information about the data.
You Yes, when you're reducing the dimension, you're losing some information. That is right.
No, the reason why g of f of xi is approximately equal to xi, or your goal to be equal to xi, is because they are inverse, no, inverse functions. If f is an inverse of g or g is an inverse of f, then you get xi. So that definitely,
Yes, ma'am.
theoretically, that is what you want to achieve. But if you don't achieve, then you get a loss. This is how it works, right?
Yeah, again, but it may not actually be true, right? I mean, we cannot actually say that this is the inverse function.
Then
Yeah,
it should be no, because an encoder will try to decrease the dimension from d to d dash. Then the
Yes,
decoder will try to
I
increase it back.
understand that. Yeah, that I understand. Like, in a way, it should be that, but I'm saying it may not be true for all the cases. When you actually come with a model, maybe it may not give you it may not be the inverse, like, for it, but it acts as an inverse operator here. That is true. It acts as an inverse operator. Then only it is able to give you the same xi when you perform this g on f of xi.
Ma'am, actually, I'm not able to understand this particular thing in the real world scenario, how it is working.
You will study in week 7. You will come across it. So
Okay,
no
okay.
need to worry about it. So dimensionality reduction you will study in week 7. I see one hand raised there.
Yeah, ma'am. So I have a
Sayan.
doubt regarding the loss of this. So as you can
Yes.
see, the loss is more or less similar to the
Regression.
regression one. Yeah. So in the regression, we were taking the difference and then squaring it, because if we take the difference, it can be positive and negative. So if we directly sum, it may cancel out. So we were squaring it. But
Hmm.
in this, as we are taking a difference of two vectors and then taking its norm, so norm of a vector will always be positive anyway, right? So why are we squaring the value here?
Norm of a vector. Okay.
It cannot
No, no,
be.
no, no, no.
It cannot
Norm,
be.
it can
Ma'am,
or
norm
cannot be,
is
no.
nothing but root. You have to remove the
Under
root, right?
root value,
Under root,
we will
yeah.
get it.
Yeah.
So if removing the under root, we have to.
Okay, so I will just write down how the norm is defined. So let's see. So let's say if you have
No,
vector x.
basically,
Yeah.
we don't need to find norm. We can stop
Hmm.
one step before. That's what my understanding.
no, actually, it's just a Euclidean distance that professor told.
It's a Euclidean distance. Yeah, that's
Yeah,
what I've
yeah.
written here.
So Euclidean distance will always be positive, right?
It's
Uh,
we get it from the square, so it's obviously with the positive side because at the distance.
Yeah. So so the values before squaring will always be positive. So
Before
yeah.
squaring, it always be positive. That's right. I think even if we don't square here, it should work.
Okay.
It
So like
should work.
maybe some
Yeah.
other reason is there for squaring.
Yeah.
No, no.
Again,
To get rid of this root, the square root, that is the
how to
reason, right?
get rid of the square root? Yes, we do it. But even if we don't do the square, still it should. I mean, still it's a
It will
good
still
enough.
be a
Good.
a
It's a
metric
good enough.
to
Yeah.
identify loss. Yeah.
Yeah, it should be good enough. Yeah, but yeah, in this case, definitely it's more like because of to get rid of this under root term. So I throughout this linear algebra part, you will be looking at the norm square instead of the norm. Uh, you look at the norm square. And also the question that somebody had asked on the practice assignment is also from encoder decoder. So maybe once we do this example, I can go back to that question and do it. Okay. So here all of it is given to you, but okay. So you have a data set. So this data set has 5 inputs here. So you have x1, x2, x3, x4, and x5. Okay. And you see this data set is in 3 dimension. Uh, you have two pair given to you. One is encoder pair. Fx is defined as x1 minus 3 x2 plus 0.5 x3, and decoder is defined as g of 0.3 u comma minus u comma u. Okay, so again, if you have to find the loss, right, so you'll have to calculate g of f of x, and you need to subtract its value from x, and then take the square, and then you sum it over all these values and take its average. So that will give you the loss. So okay, in here it's everything is calculated. So is anyone facing, like, does anybody has any problem in understanding how do you calculate these things? I mean, these basic operations, how do you perform? Like, how do you subtract a vector from a vector? Does anybody has any problem in that? Because
And why don't we really work out one row at least?
Yeah,
okay, I will just do it for one row. Okay, so let's do it for x1. Okay, so you see x1 is minus 1 1 minus 1 minus 1 1 minus 1. So what is fx? Fx is defined as x1 minus x2 plus 0.5 x3. So you will get minus 1 minus 1 minus
minus
0.5,
minus 0.5.
right? And this is what minus 2 minus 0.5, which is minus 2.5.
Yeah.
So this is what we have obtained here. Now g of u is defined as 0.3 of u comma minus u comma u. So g of u will give you, what is u here? U is this value here. Okay,
2.5. Yeah,
yeah,
minus 2.5.
this is your u. Now what you're saying is you will do minus 0.3 of u, so that will be minus 0.75, then minus u, that will be 2.5, and then you will have u, that is minus 2.5, right? So you got your fx, you got fx, you got g of fx, right? Now you need to take
Yeah.
Ma'am,
the
how did we
difference.
get g of fx 0.75, 2.5, and minus
See,
2.5?
this u is nothing but f of x. Okay, so after for this x1 we got our fx to be minus 2.5. All right.
So you get minus 1 minus 0.5.
No, so you f of x you obtained is minus 2.5, right?
Yeah, how did this come?
So
Minus
minus
0.5?
minus
Oh, okay,
2.5 we
from
got
fx.
from
Yeah,
fx,
fine, fine.
right? Now you
Okay.
do 0.3 of u, so 0.3 of minus 2.5, so you get minus 0.75, then you do 2 point, you get
Yeah.
2.5, and then you get minus 2.5. Okay, so you
Yeah.
got your g of f of x, you got your f of x. Now you want to find uh, g of f of x minus of x, right? So for x1, I am talking about just x1 here. So you will have minus 0.75, you have 2.5, you have minus 2.5, and what is x? X is minus 1 1 minus 1. So once you subtract this, what will you get? What will you get?
0.25.
Minus 1.75.
0.25,
Yeah.
1.5.
1.5.
2.5 minus
1.5.
1, that is 1.5,
And
and then
1 point
one,
minus
Minus
1.
1 point.
Minus
Minus 1 point.
1.
right? So we got this. So let's check. Okay, it's not given here. So now what we have to do is we need to find the norm of this. So let's find the norm of this, or norm square basically. So how will you find the norm square?
Square each term and add.
Right?
And
So
then, yeah, then
yes. So 0.25 square is It will
It's zero
be
six
zero
two
point
five.
zero
Zero
six
point
two
zero six
five.
two five.
Point zero two five. 3.
2.25.
2
Right?
Yes, ma'am.
2.25.
2.25.
0.225.
2.2, yeah.
2.25.
2.25.
Oh, this is
Okay.
2 point. Yes, yes, right. 2.25.
Previous one as
Yeah,
well.
yes, yes.
Yes, sir.
So if you add this, you should get
4.5. 4.5625.
yes, 4.5625. So you see that you get 4.56. So this is just for x1. Now you'll have to do the same thing for x2, x3, x4, and x5. You find all this and then you take the average of it, and that should be your loss.
Oh. So,
Yeah.
Physically, what we get from out of this data?
Yeah.
Yeah, actually, physically, what we get from out of from this data, that the computation part, the loss, dimension reduction.
Yeah, basically it's asking the
Uh,
implication of all this.
yeah. So again, this is to check, this is to check if your this encoder decoder pair that you have found, if it's uh, if it's giving you actually uh,
Decoded properly, no? To see if it is actually decoded properly.
sorry,
It is
I
to see
see
if
a
it
lot
is
of noise.
decoded properly, right?
Yes, whatever, yeah. Just to check if it's decoded properly. Some voices. Can you please mute yourself, Rajiv? Rajiv, can you mute yourself? Yeah. Uh, Only in the ideal cases, the loss will be zero. Yeah. So you would want your loss to be as less as possible, or more likely it should be zero. Only in that case, you would say that encoder decoder pair that you have found is the right one in a way. So yes.
Where is the dimensionality reduction is happening?
You see, like when you are encoding it, you are reducing the dimension. The way you have defined it, the encoder function, it should take the data set and it should take it to a lesser dimension, right? So you see that this d dash here, right? This should be less than d.
Ma'am, can you explain it in this calculation how it is reduced in encoding and how it
Um,
is reduced?
yeah. So you can see here, right? So this was your data set, and so the data set was in 3 dimension.
Okay.
Now you have an encoder function, which is defined as x1 minus x2 plus zero point 0.5 x3. So this is taking this data set into a 1 dimension, right?
Oh,
Now
yes,
this fx is
yes.
in 1 dimension. Now again, your decoder function will take this value and again convert it to uh, the same dimension, the actual dimension you had for the data set.
Okay.
Yeah. So you see, it is reducing the encoder pair is reducing the dimension.
And why do we take a norm in the end?
Because see, when you are reducing the dimension for a data set, uh, and if you when you want to get it back, right? So that is what the decoder function is doing. Like when you're reducing the dimension, you're actually losing some data, but if you want to get back the data, so that is what your decoder function is giving. So you would want that your decoder function will give you approximately the same data that you have. So you would want that, let's say if I have gotten the fx here to be minus 2.5, and now I take a decoder function and I perform it on this function, this fx. I would want that this gx that I have obtained, right, it should be almost as same as this minus 1 1 and minus 1.
Okay.
Yeah, so that is why we want this error to be as less as possible.
So your dimensions are really coming back now. You started with 3,
Yeah,
then
but this decoder pair is this decoder function is when you want to get back your actual data in a way. But like when you're reducing the dimension, like it has few applications that you will see later. So in fx you're actually reducing the dimension, right? You're going from a 3 dimension to a 1 dimension.
So actually, we are comparing with the decoder function to the main function that we have.
Hmm.
The the total loss that we get at at the end. So is it the good for us or not in that manner?
Yeah, I mean, at the end what you would want is that if you have like uh, reduces your dimension, I mean, if you have moved from, let's say, a higher dimension to a lower dimension of data set, uh, like if you want to get back the actual data, that is what I would expect the decoder function to do. So it may not give you the same xi, right? It may not give you the same xi, I mean the same data set that you have. So that is why we want to check like how much difference it is from the like this g of xi that is giving to you from this xi. So that is giving you the loss. We would want this loss to be almost zero. But to see how much the error is coming, we are doing this square loss here.
So, ma'am, if there are two pairs of encoder and decoders given,
Hmm.
we find that loss of one of the pairs in encoder is more than this loss of the second pair. Can we automatically assume the decoder is also not a good fit, or should we have to calculate the loss for decoder also?
I mean the loss. If you look at the loss function, it has the decoder function also. I mean, it has g of f of xi minus xi norm square.
Yeah. So if the example that you were taking, right, we did the calculation by taking fx and then gfx, right?
Right. That yes.
So do we have to do the reverse for the decoder also? In this particular case, we will first calculate gu, then we will calculate f of gu, and then perhaps do the subtraction. Would that be required or no? Or would it be the same results?
I think I didn't.
Can you open the slide, please? Then I'll
E-
explain.
no, no. I mean, can you repeat just the question? I think I missed the initial part. So
Okay, so if
yeah.
we have two pairs of encoder and decoders, right?
Right.
Two pairs, encoder
Hmm.
one, decoder one,
Hmm.
encoder two, decoder two.
Okay.
We calculate the loss of encoder
Hmm.
for both the pairs, and we find that encoder one has more loss than encoder two.
Okay. Okay. I get that. So
Then
we would.
can we say that decoder one is equally not good than decoder two, or do we have to calculate separately the loss for decoders
Uh,
also?
okay. So what you are saying is like if I have, let's say, two pairs of
Ma'am, could you just
FP.
write it down on the sheet so that it is.
Your screen is not shared.
Yeah.
It is not shared.
No, actually, it just switched off. The screen switched off.
Okay. Okay.
I think loss is defined by both
Let ma'am
the
answer,
encoder
Sayan.
and the
Let ma'am
decoder.
answer.
Yeah,
Uh,
I'm just giving my
No, let
opinion
ma'am
here.
answer. That's fine.
Okay, sure.
yeah. Wait. Just let me share my screen. Are you able to see the screen?
No, ma'am.
Not yet, ma'am.
Not yet.
Okay, now getting visible. Yeah, yeah, yeah.
You can see a screen, right? Black screen.
Yes, yes, yes.
Yes. So yeah, so your question is like we have two encoder decoder pair,
Yes, ma'am.
FG and let's say F dash G dash. So your doubt is like we find the loss for uh, if we find the loss for just for encoder, right? For both the
Yeah.
pair,
Yeah.
right? So okay, so my question is how exactly are you, I mean, how do you define your loss function for encoder?
One you just explained, right? G of fx minus.
Yeah, so I would all right,
So
so
we will calculate loss for
so
one
you
pair,
have
and then we will calculate
f
the loss for
from
second pair.
rd to rd dash, right? I'm
Yeah,
reducing
correct.
the dimension, d dash is less than d, and I have a decoder pair that is taking the rd dash vector from rd dash, and it should give me rd. Okay, and what we would expect is like if we have a data set xi, uh, and if I am reducing the dimension using the encoder function, so I will get some f of xi, and now if I want to get back the data, I would want it to be as same as what my xi is. So I will again do g of f of xi, and I will want that this gives me the value approximately as xi, right? So this is my goal. This is my goal, right?
Yes.
Now, so to check, now you have two pairs. You have f comma g and f dash comma g dash. So to check which one should I choose, right? So you calculate the loss first for the first pair. Let's say this is L1, this is L2. So you find first L1, and it is what? It should be 1 by n sum over again g of f of xi minus xi norm square where I varying from 1 to n. And you also find L2, right? And this is 1 by n sum over norm of g dash of f dash of xi minus uh, xi, right? Square.
Yes. Right.
So to check which one is a better encoder decoder pair, again you will look at the loss. So for whatever pair you're getting the loss to be least, that you should select as a encoder decoder pair. I would not say the loss will be zero, but the lesser it is, the better the pair is.
Okay, so we are seeing that loss is for an encoder decoder and not just for encoder, and then we don't calculate loss for a decoder separate.
No, no, no. It's
Okay,
not like that. Yeah.
fine. Thank you very much. Okay,
Yeah.
thanks.
So on the same line, I would take the last question from the practice assignment that was also asked in the at the starting. So let's take this question. So this is from practice assignment. I'm not sure what question number is.
Was it the question that I asked before?
Yes, it's the same question.
I think that is the last question then. I'm not sure. I don't know whether
Yeah.
it's jumbled for everybody.
Question 11, I guess.
Question number 11. Okay.
Yeah.
Question number 11 or 12, something. So you have three data points given, right? So you have x1, you have x2, and you have x3. So x1 takes 13 10. So again, we might have changed the notation here, so let's stick to it. So x2,
X2 is 10, ma'am. And
yeah,
X3,
so 10
X3 is 9.
13 5 8, this is x1.
Yeah.
Then
Yeah.
10
10,
12
12,
5
5,
7,
7. 9,
9 13
9, 13, 4,
4
7.
7. Okay, so this is the question from practice assignment. Now the two encoder decoder pair has been given to you. So you have the first pair, so I would say pair 1 to be f comma g, where f is defined as x1 minus x2 plus x3, and your g is defined as, so g of u is defined as u comma u
U
comma
comma U comma U.
u. Now you have a second pair, which is f tilde
Yeah, ma'am.
g tilde. Okay, and here the f is defined as f tilde is defined as x1 plus
X1 plus
x2
X2
plus
plus X3
x3 by 2
divided by
3.
3, ma'am.
Yeah, and g tilde is defined as again u, so it takes the input u. Okay, so what the question is, the reconstruction loss of the encoder decoder pair is the mean of the square distance between the actual input and reconstructed input, right? So you need to find which of the pair is in a way a better encoder decoder function. So you will find the loss again. So what I had said earlier, right? You have two encoder decoder pair, and you will find the loss for both the pairs, and then you will check which one is a better one. So I before I do it, I would say, can you please try for let's say the first pair, what is the loss that you're getting?
I got 3, ma'am.
You got the loss to be 3. Okay,
Yes.
so the loss to be 3. What about the second one?
0.66.
You got the loss to be 0.66. Okay, yeah, so do you want to try it out, or do you want me to explain this?
Let's take a stab on that one. We'll try it out.
Yeah, just try for at least one pair. Let's try first for pair 1. Yes, the loss will come as 3, but just to get a hang on it, just do one problem so that you get used to this small calculations and all.
Ma'am, in the table, it's supposed to be X subscript 1, X subscript 2, and X subscript 3, right? Not superscript.
Yes, but in the lecture we have seen it as x superscript 1, x superscript 2, so that's why I have stick to this notation here. But yeah, in the question that is given to you in the practice assignment, it's superscript, so that's not a problem. It just change in notation. Oh, okay, okay. I got what you're saying. All,
Yes.
yeah, yeah, yeah. So this is right. Okay. So actually, this is not like this. This is your x1. This is your x2. This is your x3, and this is your x4, and this is your x. Yeah. Now you can say this is x1, x2, x3, right? Yeah. Thanks.
Yes,
Thanks
ma'am.
for correcting this. Yeah. So you have 4 data point here. That is in 3 dimension, and now you have to find the encoder and decoder pair.
Then the f is x1 minus x2, only up to x3 is there.
Yes, because each of
Oh,
the
okay.
data point has like it's in 3 dimension.
I think it is on the same parameters that you explained in the previous question, no? Somewhat.
Yes, yes, it's the same. I mean,
Yeah.
hmm.
Will you be sharing these notes?
uh, I mean, here I have not written much, but yeah, I can share this.
G is, how do we really calculate the G values?
So
U.
yeah, so this u is what? U is f of x.
U is f of x, huh?
Yeah, f of x that you get from this, because this g will take the input as what you have gotten the output from f. that it will take as an input, and then convert it to the same dimension that your actual data set was.
Ma'am, here all these examples we are reducing to one dimension.
And
Okay.
you we are reducing to one
F
dimension. Then
F F. I mean, encoder pair is reducing it to one dimension. You have the data set in three dimension, right?
Yeah, but is it always one dimension, or can we go if the features are maybe five, can we reduce to two instead of one?
Yes, 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 definitely.
So in that case, there will be two functions.
Uh, no, in that case, you will define f in such a way such that, let's say, you have you have the data set in three dimension, right? Now I can define my f to be, let's say, so f which takes the input as x1, x2, x3. I can define it as, let's say, x1 minus x2, comma x1 minus x3. So this encoder function is taking this data set and data set which is in three dimension, and it is taking it to two dimension, right? So you will come across, I mean, it's not necessary that it should always be the encoder should take it to one dimension. It can take to any dimension lower than your data set, the dimension of your data set.
Yeah, thank you, ma'am.
Yeah.
so this pair one and pair two is entirely different, independent, is it? Nothing.
Yes, yes. There's no similarity. I mean, it just for you to understand, like if you're given two encoder decoder pair, how will you check which one is better?
Okay, now after decoding it, then how we are going to get the error?
You decode it, right? Now, how do you define the error? You define the error to be, uh,
1 by n
yeah. So you
sigma I or
define,
equal to 1 by
this
n
error is your g of f of xi minus of xi. You take the square. So this is, I'll just write it loss. So I varying from 1 to n, 1 by n. Right? So once you decode using the g function, this is a loss function that you'll have to calculate now.
So we are just using three dimension to three dimension, is it?
Sorry. Yeah. I mean, you got, uh, when you decoded it
Yeah.
back, you got the data to be in the three dimension. Now you have to check the data that you got after decoding, if it's the same data set, or if it's different, how, like, what's the difference? So
Okay.
whatever the difference will be, that will be your error.
Okay.
Can we move to density estimation?
Yes, we can. uh, okay. So I will stop here. I mean, you can check. I mean, the process is very straightforward. You just have to calculate the loss and check which one is better. So you can do it your own. So again, the answer I have written here. So loss should be 3, and for the pair 1, and for the pair 2 should be 0.66. So we can calculate and cross verify.
get 2.5.
Okay. There must be some mistake you will be doing. Some mistake in cross check.
Thank you, ma'am.
Yeah, thank you. Mira.
Ma'am,
Yes.
can you upload these slides in the
Uh,
supplementary content or something?
yes, yes, we will upload the slides. Don't worry. I am not sure if these notes are because I've edited a lot, so
No, ma'am, it's
but
okay. This
it's
working
okay.
is good.
Okay, okay. Yeah, I will upload. Yeah.
Okay, thank
Okay. So in case of density estimation, it is not like a predictive model, but it is more like a probabilistic model. So depending on the probabilities of the data set, you will decide whether um, it belongs. Wait, can you mute yourself? Is there? Um, can you mute yourself, Subramanyam? Can you mute yourself? Yeah. All right. So this density estimation problem is not like a predictive model. It's more like a probabilistic model. In here we are not trying to predict. Like in case of regression and classification, we are trying to predict the labels or the values for the data set, but in this case we are trying to calculate the probability, and if we see that if your probability if your probability is large, then in that case we say x belongs to your data set, otherwise it doesn't belong to the data set, right? So this is what we use to check for density estimation. um, and in this case you define your loss function to be 1 by n sum over minus of log p of xi. So this is also called the reconstruction error. So this is also the reconstruction error. So this is how you define the loss here. That is 1 by n minus of log p of xi. So
Negative log likelihood.
negative log likelihood. You have already seen the log likelihood in when you are doing the ML estimator, right? So you have found a likelihood function. Now this is this minus log of p of xi. This is called negative log likelihood. So this is negative log likelihood. And now again you want this loss to be as less as possible, right? So I think there is one problem here. Okay. So again, let's say you have a data set which is in one dimension, and it takes the values 2.5, 1, 3, 4.5, and 4.95. And let's say these are the probabilities associated with these data point. So, okay, Chanakya.
Yes, ma'am. Actually, can you explain how the loss is being defined here? Actually, what is the loss in this probabilistic model?
I'm not getting that from the video.
You're not getting that from the video. Okay, so I will take the what is taken in the like the example I will take from what is given in the lecture. So let's say I have three probabilities model uh, given to us. Okay, let's say I have two probability models. So I have P1 and I have P2. Okay, and let's say uh, this space here. Wait, I will share another screen here. Okay, let's say I have these data points. So you have x1, x2, x3, x4. Okay. So this x1 is, let's say, 2.3. This x2 is 2.7. This x3 is 4.6, and this x4 is 4.9. Now let's say I have three. I have given three three models for it. So one is P1, other is P2, and other is P3. Okay. Now, what does P1 says? How P1 is defined is P1 is defined as it takes any value and it gives me 1 by 10 when x belongs to 1 by 0. So let me write it like this. So P1 is 1 by 10 when x belongs to 0 to 1 by 10. Okay, and if x doesn't belongs to 0 comma 10, I will say the P1 gives me 0. Now I have P2. Let's say it is defined as 1 by 5, and this is x belongs to uh, 0 to 5. When x belongs to 0 to 5, it gives this P2 gives 1 by 5, and otherwise it gives 0. Okay, and similarly I have P3, a different model which gives the value 1 by 5 when x belongs to some 3 comma 8, and it gives a value 0 otherwise. Okay, so you have three models here. Now you want to check which like for which of these models the loss function is going to be the least, right? So now let's look at this x1. Okay, so x1 is 2.3. So if I look at P1, so whenever x belongs to 0 to 1 by 10, so in this case x is, what is the x value? I'm talking about P1 first.
2.3.
2.3. So x is 2.3, which belongs to 0 comma 1 by 10. So what should
Yeah,
P1 be?
1
1 by
by
10.
10.
1 by 10. Now what should P2 be?
1/5.
1 by 5.
1 by 5. What should P3 be?
1 by
Zero.
5.
Zero.
No,
Zero.
Zero.
no, no, 0.
Zero.
Zero.
0.
0,
Zero.
right?
Zero.
Similarly, you can find for all these data points, x2, x3, x4, what are the P1, P2, and P3. So I will just write it down here. So this is 1 by 10.
P3 is 3, no? Or
P3 is
2.3?
0, right? 2.3. So
2.3,
P3
not okay. Okay.
P3 is x belongs to 3 comma 8. It is 1 by 5. Otherwise, it's 0. Since it is 2.2, it is 0. So it is 1 by 5. It is 1 by 5. It is 1 by 5. This is 0. This is 1 by 5. And this is 1 by 5. Okay. So you have computed the P1, P2, and P3. Like you have computed P1, P2, P3 for all this data set. Now you need to check which probabilistic model is better. So for that you will check the loss function. So what is the loss of p1? So
Why are we taking a log in the loss function?
why are we taking the
Logarithm.
Yes,
yeah,
ma'am. That is the question, ma'am. How, why
Like
this
logically,
log?
why we are taking log?
okay, it's more like, so when you look at the likelihood function, right? So okay, this is what I would understand is it's more like to simplify uh, the calculation in a sense. Maybe if you don't put it, it gives you a very high value, the losses. So that can be one reason to put the log here. But again, to confirm, I will check it again if that's the reason the log has been taken. But this should be the reason according to what we have seen before, because
Ma'am,
it's not going to affect. Yeah, tell me.
ma'am, can you tell me what can be the loss in a probabilistic function? I mean, how are we defining a loss? I mean, in a model, how a loss can be defined for such functions?
Yeah, so the loss is defined as, the loss is defined as 1 by n sum over minus log of p of xi, where I varying from 1 to n. Okay.
No, ma'am. Actually, I'm asking that what is the loss? I mean, like in classifier models, we define loss as the how our good is model in classifying
Hmm.
zero as zero and one is one.
Right, right.
So in this sense, how
Here also it's same. So the more, uh, I mean, again, you would want the less loss, right? And here it's more like the higher the probability is, the more chances for the data set to be, I mean, the new data set to be in fall in such category. It's more like that.
okay, ma'am. Not as satisfactory that I expected, but
Uh,
okay, I will try to understand that.
uh, yeah, okay. So let's find the loss for P1. So what should be the loss for P1? What is N?
4.
4. And what is P of x1?
Minus, it should be minus log of 1 by 10.
Yes. Then again you add minus log 1 by 10. Again minus log 1 by 10. So I can just write minus 4 times log 1 by 10.
Yes, ma'am. So answer is log
So
1 by
when it
10.
comes to the calculation part, so we're expected to take log or ln.
You're expected to take ln with, yeah, you're expected to take ln.
ln of 0.1.
ln, yeah, ln.
Okay, okay.
Say similarly you find for P2, and similarly you find for P3. So again, whatever comes the least, you would be interested to take that probabilistic model. So when you solve for it, right, you will get the loss of P3 to be minus infinity. So, and these will be again some constant value which is greater than 0. So
The loss of P1 is what? It is 9.2.
I haven't calculated it, but okay, let me check.
So 9.2 divided by 4 is cancelled. So
So ln of 0.1,
0.303.
0.303,
2.303.
2.303. Yeah. So it comes as 2.30. Yes. Similarly, P2, loss of P2 will also be same, but loss of P3 will come out to be minus infinity. So, of course, looking at these three models, P1, P2, and P3, P3 is the best one we would go with.
Okay, ma'am. Thank you.
Then P2 loss of P2 is
Show me PP, ma'am.
1.60.
Oh, lost the screen.
Sorry.
He lost the screen.
Oh, okay. It's visible now.
Then loss of P2 is 1.60 and loss of P1 is 2.30.
Oh, is it?
Yes,
Okay.
ma'am. Yeah.
Okay, okay. I will
P2
correct
is
it.
1.61.
1.61, is it?
Yes, ma'am.
Okay.
Can you please scroll the screen? Because P3 is not visible.
Sorry.
Can you please scroll the screen up? P3 is not visible. Oh,
You want? Oh, okay, I didn't understand what you said. Um,
We are now not able to see the screen itself, I think.
yeah.
Hello?
Yes, yes. Yes.
Okay. Yes, yes, now we can see.
Actually, loss of P3, we all know that log of 0 is infinite, undefined. So, but there are other values as well. So, why the entire loss becomes infinite?
Uh, did you calculate the loss of P3?
Yeah, actually, it's 1 by 4, the bracket and the individual log of 0 plus log of 0 plus my 1 by
Yeah,
plus
but
minus 2 log of 1 by 5 in some way.
what is log of 0?
Undefined.
Uh, it goes to minus infinity, right? Log of 0.
log
Will
of
it
0
be
is not defined, no.
will it be some way like that undefined added to something will remain undefined?
Log of 0, it goes to minus infinity, right? Um, okay.
Ma'am, sir told like the lecture, no, he told like that it is going to, we can take it as a infinitely large or negative power value. Is approaching to a very large value.
Um, yeah, I mean, like If you look at
Undefined quantity,
look
so
at
that is we can take it as infinity.
yeah, like if you look at it from the limit
The lecture
point
told
of
like that
view,
only.
like the limit point of view, like
Yeah.
when you look at the graph of this log function, like as
Yeah,
x
entirely it
going
is
to
approaching
0,
to
it will approach to
infinite,
Yeah,
minus
infinity.
infinity.
minus infinity. Yeah.
Infinity
So
only.
from there, we are saying that the loss is minus infinity.
But what is implied in the physical sense? Basically, it's basically on the probability side. So what this the it conveys to us?
Yeah, so we saw that out of all these three models that we had got for this data set, we got the least loss to for the P3, the model P3. So hence we should like select the P3 model. I mean, this in a way it is a better model.
Not the P2 is a better model.
Uh,
Actually, it should be just around 0. But
what?
What is the P3?
No, P2, I think.
Sorry, what is the question?
Ma'am, can you show
why
what is the P3 values are? Because that's not visible in the screen.
P3 is 0, 0, 1 by 5, 1 by
No, no,
5.
no,
Ma'am,
no.
he's asking for the function, ma'am. He's asking for function.
Oh,
Function.
okay, okay. 1 by 5, 0.
3 and 8.
it's
Infinity.
uniform 3 8.